Malaria, a deadly disease, has plagued humanity for centuries. For years, quinine, derived from the bark of the cinchona tree, was the primary weapon against this parasitic infection. However, the emergence of drug-resistant strains of the malaria parasite, Plasmodium falciparum, threatened to render our existing treatments ineffective. The search for new and effective anti-malarial drugs became a global health priority. In the 1960s, during the Vietnam War, Chinese scientists embarked on a mission to discover new anti-malarial medications. Their search led them to ancient Chinese medical texts, where they found inspiration in the use of sweet wormwood, Artemisia annua, for treating fevers. This plant, used in traditional Chinese medicine for over 2,000 years, held a secret weapon, Artemisinin. Tu Youyou, a dedicated Chinese scientist, meticulously analyzed ancient texts and conducted numerous experiments, finally isolating Artemisinin from Artemisia annua in 1972. This discovery was a major breakthrough and earned Tu Youyou the 2015 Nobel Prize in Physiology or Medicine. Artemisinin and its derivatives, collectively known as artemisinins, have revolutionized malaria treatment. Today, artemisinin-based combination therapies, ACTs, are the first-line treatment for uncomplicated malaria caused by Plasmodium falciparum. Artemisinin's rapid action and ability to quickly reduce parasite load have made it a game-changer in the fight against malaria. The effectiveness of artemisinin against malaria lies in its unique mechanism of action, primarily targeting the parasite's Achilles heel, its iron metabolism. The key to artemisinin's potent anti-malarial activity lies in its unusual chemical structure. It possesses a unique endoperoxide bridge, a highly reactive oxygen-containing structure that acts like a dormant bomb, waiting for the right trigger to unleash its destructive power. When artemisinin enters the bloodstream, it remains relatively inert until it encounters the malaria parasite residing within red blood cells. The parasite, as part of its growth and multiplication, digests hemoglobin, the iron-containing protein responsible for oxygen transport in our blood. This process releases free iron within the parasite's digestive vacuole, the very trigger that activates artemisinin. The iron in the parasite's digestive vacuole reacts with the endoperoxide bridge of artemisinin, triggering a cascade of reactions that generate highly reactive oxygen species, ROS, such as free radicals. These ROS are incredibly destructive, causing widespread damage to the parasite's proteins, lipids, and DNA. This cellular damage effectively kills the parasite, reducing the parasitic load in the body and providing relief from malaria symptoms. The remarkable success of artemisinin in treating malaria has spurred research into its potential against other parasitic diseases. One such disease is schistosomiasis, a debilitating parasitic infection caused by parasitic flatworms called schistosomes. Affecting millions worldwide, schistosomiasis can lead to liver damage, intestinal problems, and even bladder cancer. Laboratory studies have shown that artemisinin and its derivatives exhibit promising activity against various stages of the schistosome life cycle. Although the exact mechanisms are still under investigation, research suggests that artemisinin might exert its anti-schistosomal effects through multiple pathways. These include damaging the parasite's tegument, its outer protective layer, and interfering with its energy production processes. Beyond its direct antiparasitic effects, artemisinin has also demonstrated intriguing anti-inflammatory and immunomodulatory properties, offering potential benefits in managing chronic inflammatory and autoimmune diseases. Studies suggest that artemisinin can modulate the activity of immune cells, such as macrophages and T cells, which play crucial roles in inflammation and autoimmunity. Anti-cancer potential. Cancer cells are particularly vulnerable to artemisinin due to their high iron intake. Artemisinin exploits this characteristic by generating ROS within tumor cells, resulting in mitochondrial damage, DNA fragmentation, and apoptosis. It also interferes with tumor angiogenesis and metastasis, offering a multi-pronged approach to cancer treatment. While more research is needed to fully understand its therapeutic potential, early findings suggest that artemisinin might hold promise as a novel immunomodulatory agent. Artemisinin and its derivatives are generally safe and well tolerated when used appropriately. However, like any medication, they can cause side effects, though these are usually mild and temporary. The most common side effects include nausea, vomiting, dizziness, and headache. In rare cases, more serious side effects, such as liver problems and allergic reactions, have been reported. Artemisinin is available in various forms, including tablets, capsules, tinctures, and injections. The most common and effective form is artemisinin-based combination therapies, ACTs, which combine artemisinin with a longer-acting anti-malarial drug. These combinations are more effective in treating malaria and help prevent the development of drug resistance. While artemisinin is a natural product, it's crucial to remember that not all artemisinin products are created equal. Only pharmaceutical-grade artemisinin derivatives, manufactured under strict quality control standards, should be used for medicinal purposes. These products ensure consistent potency and purity, maximizing efficacy and minimizing the risk of adverse effects. Before taking any artemisinin-containing supplements, it's essential to consult with a healthcare professional. They can assess your individual health status and determine the appropriate dosage. Pregnant women and individuals with certain medical conditions, such as liver or kidney problems, may need special precautions or dosage adjustments. Follow for more powerful health facts grounded in real science.